Okay, hi again, guys. So I believe you've finished the first video. I hope you finished the first video before moving forward to this one. So I'm just showing you here, reiterating that you should have accomplished this activity number 4 here when you are done watching that first video about time dilation. Okay, so at this point, we will be moving forward with length contraction. Okay, so what do you mean by length contraction? So this one is another effect of the two postulates that we have stated or consequences of the two postulates that we have stated in the first part of this discussion. Okay, so the first one is a time dilation. Umiikli yung oras kapag ka ino-observe siya nung observer in the moving reference frame. Well, hindi naman talaga niya exactly nakikita na bumabagal yung oras, pero kung i-compare niya, once na kinompare niya yung oras niya with an outside observer, that's when we will see the difference. Okay? So the next one naman, the length contraction, it also has a sense of shortening of something. This time, it is pertaining to the shortening of the length of an object as it approaches the speed of light. Okay? So at this point, the difference in this situation is that the shortening of this length will be observed by the outside person or the outside observer. Diba? Kasi nagkaroon tayo ng pag-iksi ng oras. Naging effect nun is kapag ka tumatakbo ka ng mabilis, di ba? So nakikita siya or nangyayari siya doon sa may frame nung gumagalaw na vehicle or moving reference frame in general. So nagkakaroon ka ng pag-ikli ng oras, pag i-compare mo na yung oras ng dalawang observer na yon, makikita mo na meron talagang effect in terms of the time, right? This case naman, hindi naman talaga siya in reality um, if we're going to look at it, uh, physically on board, like for example, the same situation that we have in a time dilation wherein we have a spaceship and then you have this astronaut traveling near the speed of light, and then you have an observer on Earth looking at this spaceship here moving near the speed of light. Let's say the 80% the speed of light again. So kapag ka-inobserve yan nitong person on Earth, ang sasabihin niya doon sa length nitong spaceship na 'to will be shorter than what this astronaut would be telling us. Okay, kasi yung true length, ire-record ni astronaut as he is looking at it um, when he is or when he or she is on board, 'di ba? So, kung ano yung actual na nakikita niya habang nandun siya sa may spaceship na yun, yun yung i-record niya ng oras. But it would be a different observation if we're going to ask this person on Earth. Okay, kasi let's say for example, sasabihin nito, ang length ng kanyang spaceship nung kanyang sinukat ay 20 meters. For example, no, medyo malaki. So, 20 meters, di ba? Pag si observer on Earth, yung tinanong mo, given this 80% the speed of light, I'm just approximating here just to give you the idea. But syempre, we will have to solve things eventually to give you the exact value. So let's say, for example, this person would be telling us 15 meters. Okay, ang nare-record niya ngayon or ang sasabihin niya ngayon na observation sa'yo is shorter than what this astronaut would be recording. Bakit? Kasi habang mas bumibilis ang speed ng isang frame or ng isang object, mas lumiliit yung length niya kapag ino-observe ng observer outside of that moving reference frame. 'Di ba itong tao na to sa Earth, wala naman siya dun sa may moving reference frame eh. So, he is outside of that moving reference frame. So kapag ka ino-observe niya yung nagmo-move na spaceship na 'to, ang magiging observation niya is shorter ang length nitong spaceship na 'to. Okay, so that is what we mean when we say shortening of length an object experiences as it approaches the speed of light. Okay? Ulitin ko, hindi naman talaga umikli yung length niya, but if it will be observed by this outside observer, not in the moving reference frame, he will be observing a shorter length compared to this astronaut on board. Okay? Yan po. Okay, sige, move forward tayo with the next is okay. So we have here now an example to emphasize that concept of length contraction. So as you can see here, we have this ball that is at rest, the first figure, this one, v sub 0. So this is the actual size of this ball. And if we're going to let someone observe this ball while it is at rest and traveling eventually with varying speed, he will have this kind of observation. Let's say this is a meal, no? So if the ball is at rest, he will be observing this ball having this kind of length. Okay, length and height. So length, for example, let's say is 0.10 meters. Yan, ito. Also with the height, it's also 0.10 meters, let's say. Okay, the height and then the length, no, the diameter of this one. So let's just say that the length in this case. So if this ball will be thrown with a speed that is equal to 0.87 c or 87% the speed of light, what do you think happened in terms of its dimensions for the height and then the length? So if we're going to observe the height, nothing changes, right? So you still have that 0.10 meter. If you're going to observe it from top to bottom, it still has that same 0.10 meter height. But if we're going to look at the length uh, of this second figure here, while it is traveling 0.87% the speed of light, it is obviously less than 0.10 meter this time, right? So ito yung sinasabi natin when we say there would be a decrease in terms of the length if it is traveling with a huge amount of speed, okay, or traveling near the speed of light. So if it will be observed by this person on Earth, somewhere at rest, having this kind of speed, he will be noting that there would be a less than 0.10 meter length this time. And it will also decrease even more if we're going to increase the speed. Okay, so V would be equal to 0.995 c. Let's say it's 99.5% the speed of light. So what happened now? You still have that same length. You still have that same height value for the height. It did not change, but the length this time decreases even more compared to the 0.87 c, di ba? Mas lumiit yung length niya habang mas tumataas yung speed. And you can just imagine what will happen if you have a speed that is 99% the speed of light. Okay, 99.9% the speed of light. Just like what we have in the fourth figure. And what more if you have a v that is equal to the speed of light, right? So they are inversely proportional as observed by an outside observer. Okay? Kasi 'di ba yung moving reference frame natin dito yung bola. It is the one that is moving. And you have this person outside just observing this moving reference frame. So siya yung makaka-observe nung decreasing or shortening of length na yon in his perspective or in his frame. Okay? So as the speed increases, length in the direction of motion decreases. But you have to take note that it only happens in the direction of the motion. So take a look at this arrow here. You have the blue arrow telling us where this ball is moving towards. So it is moving towards the right side. And that's the reason why the decrease in terms of the length as observed by this person here will only happen in the horizontal dimension. 'Di ba? Kasi horizontal siya gumagalaw eh. So kung horizontal yung movement niya, dun lang mangyayari yung length contraction. Okay, this is a very important detail. Please take note of this. Okay, pag na-miss out nyo to, well, this is a very important part of the concept of length contraction. Pag na-miss out nyo siya, yun nga, medyo mawawala kayo, no, in terms of its concept. Okay, so again, I would like to emphasize that this length contraction will only happen in the direction of the motion. So all the things that is perpendicular or those motion or those dimension in 90 degree 90-degree measurement compared to the motion will not be affected, just like what we have here for the height, di ba? Hindi naman siya nagbago in terms of the height. We still have the 0.10 meters in here. Di ba? Ganun pa rin naman siya kataas. But if we're going to look at how this person would be observing this ball in terms of its length horizontally, there would be a decrease. And it will be decreasing um, as it increases the speed of light. Okay? So, ulitin ko po, kapag ka bumibilis yung oras, ang nagiging consequence naman for the length as observed by an outside observer is it will shorten in the direction of the motion. Okay, kung saan siya gumagalaw, yun lang po yung length na maaapektuhan. Sana nakuha po yun, no? So, if you will be having this ball moving towards upward, let's say for example, the one that will be affected now will be the height. Diba? Yung height na niya yung maapektuhan. So, parang magiging ganito yung itsura niya. Okay? Mas parang magiging paoblong siya in a vertical direction. So, you still have this 0.10 meter length here horizontally, but the height in the vertical direction will be lessened if we're going to throw this ball upward with this series of velocities here. Alright? Sige, so for length contraction naman, we have this equation, L is equal to L sub 0, square root of 1 minus V square over C square. Alright, so we have here L is equal to L sub 0 square root of 1 minus V squared C squared, just to repeat. Okay, so the L sub 0 is what we will be referring as the proper length. Okay, so 'di ba meron tayong proper time nung nakaraan. Yung proper time, siya yung nare-record na oras nung tao doon sa moving reference frame. So this time, it will still be the same. The L sub 0 will still be the length recorded by the moving reference frame. So we will be calling this the proper length as recorded by an observer in the moving reference frame. Okay? Yan. Yung gumagalaw na frame, kung ano man yung length doon, then that's your proper length. And this L, it will be the relative length recorded by an outside observer. Yung hindi nakasakay doon sa moving reference frame. Alright? So that's the relative length. And this is what you'll have to remember. If for time dilation, that the proper time would always be less than the relative time, 'di ba? Kasi 'di ba mas maikli yung oras as you go faster, your time will be shorter. For length contraction naman, the LO would always be greater than the relative length. Kasi as you go faster, this outside observer will be measuring the length to be shorter than recorded by the observer in the moving reference frame. Ulitin ko po, sa Tagalog, habang bumibilis yung speed, yung nandoon sa moving reference frame, mas bumabagal yung oras niya. And at the same time, yung observer outside naman, yung length na nakikita niya doon sa moving reference frame is mas lumiliit. So, kumbaga, bawat isa sila merong effect na nangyayari sa kanilang dalawa. Yung nagiging effect doon sa moving reference frame, bagal yung oras niya. Okay? Yung nandoon naman sa may outside reference frame, yung nag-o-observe lang ng gumagalaw na object na yon, yung length naman na nakikita niya is less than. what's the proper length really of that moving reference frame. All right. Then of course you still have this square root of 1 minus v square over c square, which we call the Lorentz factor. Okay, yan. So you can actually write it in this simple symbol, but we will be opting to use this one to, of course, since we will be substituting the value of v. And this is what you'll have to remember for the Lorentz factor. It will always be less than 1. Okay? Hindi po siya po pwede maging equal to 1 or greater than 1, because if that's the case, um, kapag ka po siya kasi ay naging um, equal to 1, less than, I mean greater than 1, it's not physically impossible since this v here would always be less than the speed of light, diba? Kasi itong v na to, this is the velocity of the moving reference frame. Eh, wala naman tayong velocity that is equal or greater than the speed of light. So if it is equal to the speed of light, letter c lang siya, maka-cancel yung c squared mo dito, you'll have your square root of 1. So equal lang silang dalawa, which is not possible as of the moment since we don't have anything that is equal to the speed of light. All right, and there's also nothing greater than the speed of light, so you cannot have anything greater in value for c in substituting for v here. Wala kang po pwedeng ilagay na 1 point, let's say 1.22 c. Diba? Kasi hindi naman po pwede magkaroon ng 100%, 122% greater than the speed of light. Okay, or 122% the speed of light, I mean. So, wala pong ganon. It's just always 90 na, pa pwede lang is 99.9%, but not equal to 100% the speed of light. Alright? Actually, hindi pa nga masyadong possible as of the moment ang 99.9% kasi it would require tremendous amount of energy, as I have mentioned in the previous video. Alright, let's have sample problem number 1. So sample problem number 1, a 600-meter long spaceship passes by the Earth. What length would the people on the Earth say the spaceship was as it passed the Earth at 0.80 c, or 80% the speed of light? So here's our situation. The 600-meter long was measured by the um, astronaut on board because it is measured when the spaceship is stationary. Kasi kung nakasakay ka sa isang vehicle, for you, that vehicle will be stationary. Diba? Kasi nandun ka mismo eh. You're not observing from the outside perspective. So this 600-meter here will be our L sub 0 or our proper length. Okay, 600-meter long. And of course, the speed of the moving reference frame is 80% the speed of light, or 0%, 0.80 c. And the one that is being asked for us to solve is the relative length. Okay, what do you think will be our answer? Actually, even if we're not going to solve it yet, you should know that the answer that we should be getting is less than 600 meters, right? Because our concept earlier is we have emphasized earlier that L sub 0 would always be greater than relative length. 'Di ba? Kasi nga, habang bumibilis yung takbo nito, dapat pag ino-observe na siya ng tao dun sa Earth, mas maliit na yung measured niya na length. Mas maliit na para sa kanya pag tinignan niya yung spaceship na yon. Okay? So we are expecting to have a measurement that is less than 600 meters. So what's our equation? L is equal to L sub 0 square root of 1 minus v squared over c squared. So you don't have to do any derivation. It's obviously this equation already. So all we have to do is just substitute. So the L sub 0 is 600 meters. Then square root of 1 minus the v is 80 c square over c square. Okay, so you just do the math. You'll be able to get the answer, which is equal to 300 meters. All right, so let's check if we got the concept of if let's check if the concept is acceptable. So 360 meter is less than 600 meters. So yeah, that's a check for us. All right? So kasi 'di ba, again, si observer on Earth, makikita niya na yung spaceship is less than 600 meters. So kapag ka-solve natin, malalaman natin nga na ang naging observation pala niya is 360 meters na lang yung length ng spaceship na yon kapag ka tumatakbo siya with 80% the speed of light and pinapanood siya nung observer on Earth. Yan po. Sige, let's have the next one. So sample problem number 2, a spaceship traveling at 50% the speed of light to the Earth is 45-meter long as measured by its crew. How long is the spaceship as measured by the mission control in Texas? It's actually the same thing. You're still solving for the L, the relative time, right? Kasi this 45-meter long is measured by the crew of this spaceship or the ones on board. So it's obviously the sub-zero, our relative length. So 45 meters, and then the V is 0.50 C. So yeah, just the same one as the example problem number 1. It will be L is equal to L sub 0, square root of 1 minus V square C square. Then you substitute 45 meters, square root of 1 minus 0.50 C square over C square. You do the math, it will give you your 38.97 meter or 39 meters. Well, let's check. Is it is the length observed by the people on Earth is less than 45 meter? Yes, it is. Because you only have 38.97%, 38.97 meters as observed by the mission control in Texas, which is on Earth, right? Sige. So let's have the next one. Okay, let's have a different case here wherein what we will be looking is the proper length. All right, so a spaceship 200-meter long as seen on Earth moves by the Earth at 0.8070 C. What is its length as measured by an spaceship bound observer? Okay, so this 200-meter long is the observation made by the people on Earth. So since they are at rest in the situation, you will be recording this 200-meter length to be our L, right? To the relative length. So 200 meter. And then the velocity is 0.80 uh, 0.870 C. So we're looking for L sub 0. So this is a very simple derivation since you would only be needing to divide both sides with this whole Lorentz term here. Diba? You just simply need to divide both sides with square root of 1 minus v square over c square. So both sides po yan. So you'll have your equation L sub 0 is equal to L over square root of 1 minus v square over c square. So there you have it. All you just need to do now is to substitute the values. So L is 200 meters over square root of 1 minus, what's our velocity? 0.80 c square. Sorry, walang si Einstein. And then over the c square. So you do your math, L sub 0 now. If we're going to divide 200 meters with the answer in the denominator of square root of 1 minus 0.80 c. Sorry, the square is on the outside. Yan. C. Over c square, your answer will be, okay. Alright, so the answer to that, sorry nawala po yung annotation because of some technical, yeah, problems. So, you just, kung slide na lang ng konti yung video, you'll see the solution. So, once you do the math of that, you solve that values that I have substituted, you'll be able to get this answer 405.64 meters. So it's almost half of uh here recorded by the observer on Earth. Okay, so at this point, you will be having this problem solved by you. I hope you try, please, to answer this one. If you're able to get the 0.91C, then congratulations to you. You have the hang of you actually have already get the hang of it. And Poha. So once you're done with this one, you'll be answering activity number 5 in Canvas. So that's what you will be accomplishing after you've finished this two videos here. Okay, so if you have any question, you can just message me in Teams. I'll actually be posting a thread on this or asking you to share your questions with me when we resume face-to-face class.